In problem number 12, we're asked to find the equation of the line tangent to the function at the given x value. In order to find the equation of a line, there's two things we need, and that's a point and a slope. First, to find the point, all we have to do is plug the x value into the function. So we'll have 3 times x squared minus 1/2 x when x is 2. So we'll just plug that in. 3 times 2 squared, that's 12, minus 1/2 of 2, which is 1, gives us a functional value of 11. That means we're talking about the point with an x-coordinate of 2 and a y-coordinate of 11. Next step is to find the slope. Well, the slope of the tangent line comes from the derivative. So the very first thing I'm going to do is find the derivative of f of x. So I'll go back to the function and just use the power rule. For 3x squared, the derivative is 3 times 2, 6, x to the first power. And minus 1/2 times x, the derivative of that, since x is taken to the first power, bring the power down. 1 times 1/2 is 1/2, and then subtract 1 from the power, and we're at x to the 0. So that means this will simplify to x squared minus 1/2. We want to find the slope when x is 2, so I'm going to take 2 and plug it into my derivative function, 6x minus 1/2. When I take 2 and plug it in there, we'll have 12 minus 1/2, which is 11.5, 11.5. That's fine. Now I have my slope, and I have my point. Using those two pieces of information, I can write the equation of the line as y minus the y-coordinate of the point is equal to the slope, 11.5, times x minus the x-coordinate of the point, 2. If we're going to find the equation of the line tangent to g of x when x is 0, we're still going to do the same two things. I need to first find a point, so I need to find out what g of 0 is. And that's going to mean plugging in 0 for x into our function e to the x minus cosine of x when x is 0. Well, anything to the 0 power is 1, and the cosine of 0 is also 1. So that means our functional value is 0. It also means that we're talking about the point when x is 0 and y is 0. So it's just at the origin. The next thing we have to do is find the slope. That's going to come from the derivative. And the derivative of g of x is going to be the derivative of e to the x, which is e to the x, minus the derivative of cosine, which is negative sine. Simplifying that expression, we get e to the x plus sine of x. Now, to find the slope when x is 0, I'm just going to take 0 and plug it into my derivative function, e to the 0 plus sine of 0. Anything to the 0 is 1, and the sine of 0 is 0. That means I'm talking about a slope of 1. Now that I have my slope and my point, we can put it all together to come up with the equation of the line. Y minus the y-coordinate is equal to slope times x minus the x-coordinate. And obviously simplifying, we end up with the line y equals x. Let's try one more. Find the equation of line tangent to y equals 2x minus 4 when x is negative 10. So I need a point and a slope. The point will have a y value of 2/3 x minus 4 when x is negative 10. So we're talking about negative 20/3 minus 4. Of course, to add or subtract fractions, we need to get common denominators. Negative 20 minus 12 is negative 32 over 3. So we're talking about the point with an x-coordinate of negative 10 and a y-coordinate of negative 32 over 3. Now that we have a point, we have to find the slope. And that's going to come from the derivative, and the derivative of 2/3 x is 2/3. The derivative of minus 4 is 0. So our slope is 2/3, no matter where we're talking about, which kind of makes sense because y equals 2/3 x minus 4 is a line with a slope of 2/3. But now that I have my point and my slope, I can come up with the equation of the line. Y minus the y-coordinate, negative 32/3, is equal to slope times x minus the x-coordinate, negative 10. When we simplify here, we get y plus 32 thirds is equal to 2 thirds times x plus 10.